So here, if, step two is to identify organization's key business initiatives. So, uh, what are the metrics that are important to this? What are the KPI? What are the KPIs? So primary research is required to understand an organization's key business initiative so as to actually implement the big data solution. So for each identified business initiative or opportunity, capture key information such as business stakeholders and their roles, responsibilities, and expectations. Key performance indicators and the metrics against which success of the business initiative should be measured, time frame for delivery, critical success factors, desired outcomes, key tasks. All of these information are really very important. So also, after you be able to identify your key business initiative, then you can now brainstorm and decide on big data business impact. So there are four ways that big data and advanced analytics empower an organization's key business initiative. These are summarized here. So talking about big data business drivers and data monetization impact. So we have transactional data, which are more detailed transaction data such as point of sales, call with detailed record, and credit card details. So it enables more granular, more detailed decision. Talking about localization, seasonality, and multi-dimensionality of some data sets. Also, we have unstructured data like email, consumer comments on social media, some external social media data, device data. So this enable complete and accurate decisions, new metric dimensions, and dimensional attributes. So this can also uh, come in when we talk about product development. So if the company talking about a company that's producing a particular product, you can get some insight from customers' comments on social media about the product and all of that, even in comparison with competitors' products. So we also have data velocity. So how frequent are these data coming in? So real-time data access to enable more frequent, more timely decisions can be hourly, weekly, on-demand analytic model update. So predictive analytics, causality, predictors, instrumentation, and experimentation. More actionable, predictive decisions. So that's optimize, recommend, predict, and forecast based on the models. Um, Going back to step four, that's after you brainstorm and decide, break down the business initiative into use cases. So in this step, we should capture this following information: targeted personnel and stakeholders, including their role, responsibility, and expectation. Questions that the business stakeholders are trying to answer. So what are the things what are their problems? Because everybody has questions that are needed to be answered. So what are the questions? So business decisions and the supporting decision process. So we will also keep our performance indicators as KPIs and key metrics against the success of the business is measured. So for example, I can have, let's say, revenue of a particular organization. For you to for they to consider you or consider your solution to be a success, if they can say, okay, you have to increase the revenue by 20%. So that's metrics against their success factor. So they can say you can increase their revenue by 20%, then you consider what you've done as a success. So also you have data requirements, uh, identify analytic algorithms and modeling requirements. So what are the algorithms needed? Kind of models you need to do? Capture user experience requirements. which should couple closely with the user's decision-making process. Also, okay. So after we break down business initiative into use cases, then you can now prove out the use cases. The proof of value analytic process includes this: gathering required data from both internal and external data sources, and integrate this data into a single data platform. Define and executing data transformation process necessary to cleanse, align, and prepare the data for analysis. Spend most of the time doing this anyways. Also define the analytic testament. So what's develop and fine-tune analytic models against defined KPIs and critical success factors. Now, uh, here you have to maybe tune your model, then and all of that, optimization and all of that. Yeah, also defining user experience requirement and developing mock-up or wireless or wireframes. Here includes when you have to maybe test your model and like review your model against user experience. So here, but no, you want to be the model. There are customers that are going to consume this model. So this final stage is where you now test the model against all those metrics and try to see whether it's working fine before you now implement. So design and implement phases are the last stage here. Design and implement the big data solution. So based on the source of the class, shall not be okay. So based on the sources of proof of value analytic lab process, defining and building the detailed data models, analytic models, technology architectures, and production roadmap are started. So everything, whether you want to integrate the model into an app, whether you want to, anything you want to do with a model, so this is the final stage after you'll be able to review. So the thing is to now implement it. So this helps in integrating analytic models and insights into key operational and management systems. So whereby they will now be the model will now be of use for operational activities and for management activities. So the implementation plan and roadmap should address the following key factors: data sources and data requirements, instrumentation strategy, real-time data access analysis requirements, data management capabilities, data modeling capabilities. What are the business intelligence that being drawn from the model? Advanced analytic capabilities, that's DASCA analysis, predictive modeling, and data mining, and also user experience requirement. So, some examples of solution engineering uh, here. So, some examples of organization leveraging big data business areas are key business initiatives empowered by big data, customer behavior analytics, fraud detection. All of these are examples of solution engineering. The fraud detection model is being solution put in place to do checks on transaction maybe in kind of retail, maybe in retail sector to try and detect fraudulent transaction and all of that. So big data opportunity in customer behavior analytics is to combine detailed customer transaction data such as sales, returns, customer comments, and web clicks with new social media and mobile data. So the goal of combining this is to uncover new customer insight that can optimize customer engagement lifecycle process like marketing, targeting, segmenting, acquisition, cross-sell, upsell, retention, and all of that. So this will help the business to make some useful business decisions like profiling your customer, uh, advertising some specific products to some target audience, segmenting your customers into different pockets, acquisition of new customers, and all of that. So Also talking about, I think we are not going to put it there. But to gain new insights into customer behaviors, an organization can implement the following solutions. So integrate all customer engagement transactions into a single or virtual data repository. So gather all this information into a single pocket, a single store. We use advanced analytics to analyze the data we have gotten, integrate and cleanse all prospect data gathered, augment the customer and prospect data with third-party data, that can be social media data, capture and aggregate relevant social media data about products, services, and company. We use text analytics or Hadoop's map produced to mine the social media and blog data, search, monitor, and capture relevant projects and company comments, and leverage mobile app abilities to provide real-time insights about customers' location, purchase behaviors, and propensities. Okay. Also, big data provides new and innovative technology to identify potentially fraudulent activities in real time. So here are some relevant ways of using big data for fraud detection. So first, you deploy a real-time data platform that can capture and manage high volume of real-time data feeds from multiple internal and external data sources. After you have that, then you use in-database analytics to accelerate the development and refinement of fraud prediction models based on a historical trajectory. So based on all this data you have gotten in real time, you can develop some analytic models. Then use predictive analytics to analyze real-time transactions, employ advanced data enrichment techniques to create more advanced profiles of potentially fraudulent activities, behaviors, and propensities. We have some machine learning programs that can help you do this. The insurance, we have some fraudulent fraud detection models that helps in developing. Though in this case, I'm machine learning are based on historical data, like uh, how do I put it? Like for example, in machine learning model that identifies spam emails. So it's already been fed with such mails so that it can use that experience to identify future uh, future spam mails. So take for example, if the model can be wrong in some cases, but when the model is wrong, then it also learns that okay, then it puts that particular instance whereby it fails to identify that email as spam. So if that email is not recorded as spam now, it stores that information into its maybe its repository and use that also to identify future occurrence of such kind of experience. So in this case also, insurance makes use of these models to identify fraudulent claims and to identify fraudulent claims. Okay, then it's going to segregate some things that these claims can be fraudulent. So they will now investigate more on that claim and trying to find that the person uh, is actually not filling down a fraudulent claim. So so those kind of so that's what machine learning is all about. So to learn from experience, to learn from experience. So so they can also leverage social media data to identify networks or association of potential fraud cohorts. So that's basically it. Let's look at the next slide. Now, talking about challenges of big data solutions. So, few common challenges of big data solutions is lack of comprehensive approach of processing big data, unavailability of right approach to categorize data, lack of infrastructure for turning big data into big insights, and also lack of big data skills. I think this encompasses it all. If there is no expertise, someone that is the expert in it to lead the big data solution engineering, then it's a no-go area because the skills are not available to implement this solution. Also, so some other issues while implementing digital solution are as follows: rigid business intelligence, data warehouse, and data management applications, obstructing businesses from identifying and exploiting creating short-lived business opportunities. The, the business intelligence is just too rigid. You can't really see directly, and some data warehouses are just so rigid that it's so difficult to even get data from it. And the data management architecture is so rigid that to even find relation between tables is very difficult. So these are some challenges also that is facing big data. Also, traditional reporting formats using aggregated data in batches cannot leverage new analytic capabilities to develop predictive recommendation that can guide business decisions. So here we're talking about having to have access to data in batches instead of real time, which is going to this is going to how do I put this? It's going to affect real-time decision in that regard. So mobile or machine-generated data insights are not available in a timely manner in a world where the real-time customer experience is becoming a norm. Also, data aggregation and sampling destroys valuable nuances in the data that are key to uncovering new customer, products, operational and market insight. So having not be able to having the challenge to, to leverage the whole data set and the whole population rather than just taking samples from the population. So while implementing a big data solution for a telecommunication service provider, which of the following steps of solution engineering process would help you identify analytics algorithm and modeling requirement? That is, that's break down the business initiative into use cases. So that will make you now to identify the analytic algorithm and modeling requirements to use. Because if you have not broken it down to use cases, then there's no point talking about analytic algorithms and modeling like that. And here, I think you have more of this if you can go through your what's it called, the material. Please, if you were to go through your material, if you were to go through your material, it's very important. There are so many details or some details that are left behind. So don't just rely on the slide online here. So which electronic customer activities must be used to integrate customer transactions, sales history, and you have the summary afternoon. So that brings us to an end of this session. I don't think we will cover this next session, but let's see how far we can go in a couple of minutes. So here we are going to be talking about data cleaning and processing, which is very essential, very essential. So here we'll be talking about to understand why we need to process data, need for cleaning data, understand how to handle missing data, identify misclassifications, and graphical models for identifying outliers. Also perform data transformation with normalization. Hello, are you still with me? Hello? Hello? No. why do we need to process data? So much of the raw data contained in databases is unprocessed. It's unprocessed, incomplete, and noisy. So in order to be useful for data analytics purposes, database needs to undergo the processing. So in the form of data cleaning and data transformation. So data analytics often deals with data that has not been looked at for years, so that much of the data contains field values that have expired, are no longer relevant, or are simply even missing. So the overriding objective is to minimize garbage in, garbage out. That is to minimize the garbage that gets into our model and garbage that even that our model gives out. So we want to avoid this. That just not just to get the data passing into the model, and we have to process the data. So data cleaning. So if we look at this um, table, I will see that's customer ID, zip code, gender, income, age, marital status, transaction amount. Now, the column customer ID is fine. Now, the column zip, we have we have some zip code with 5 characters. That's some with 6. That's some with 4. That's one that has data. So you might want to investigate into this, why we have all of this. Then you have the gender. You have M, F, M, which is male, F, which is female, and we have one that's there's no gender. How do we identify this gender? And we have income here. So if you look at this income column, we have one with a negative sign, which might look like it's kind of an error due to data entry. And if you look at this, that has 9,999, which might look like there's something wrong with it. It can be a missing value that's been tagged as that value, because sometimes they use 99999 to represent missing value. So you might want to investigate that, or maybe it can be due to approximation. Now you have this one column called age. Inside this age, you have the one that contains C, and you have the one that contains 0. Now this can be solved. This one that has C can be such that, let's use the instance of the Google form. If you put uh, your form, instead of it to be numeric, you put it as character or text value, then you can have um, entries like this. Have entries like this. Entries like this. Because normally you're not supposed to have this in the database, even if you want to insert, because you will have described, unless you describe age to be a character instead of a number. So you're not supposed to have a character here. So this one is 0, and you have to investigate this, because there's no one that will have age 0. It's even though it's in years. It's in years. It can be 0. It can be, maybe it can be 7 years. Maybe the person is 6 months or 9 months. It's not a year, depending on the kind of data it is. So you have to know. Then you have marital status. You have MWSSD, and this can be so confusing sometimes. So you can say, can we say W is wedded or widow? Maybe it might need some kind of investigation. Like S can be single or separated, but D, divorced. Uh, divorced is fine. So you might need to put up some investigation with regards to this also. Now moving forward, so talking about handling missing data. So missing data is a problem that continues to create data analysis methods, especially in database with a large number of fields. Therefore, we should think carefully about how we handle the issue of missing data. So, a common method of handling missing data is simply to omit the records of fields with missing value from the analysis. I just decided to do it, like to omit the records entirely. Now, that can be so wrong. That can be so wrong. So, I'll come back to that. So, however, this may be dangerous as the pattern of missing values may in fact be systematic, and simply deleting the records with missing values will lead to a biased subset of the data. Further, it seems like a waste to omit the information in all the other fields just because one field value is missing. So it's really a waste, not that it seems like. So therefore, the data analysts have turned to methods that would replace the missing value with a value substituted according to various criteria. So let me give an instance. Say I have, so let me use the whiteboard marker. I have a scenario such as this. Say I have a table called DF. So I have a table called DF. It has these three columns, say X, Y, and Z. And should I use X, Y, and Z? No. Let me say I have this one to be gender, this one to be maybe, what should I call it? Salary column. And this one to be what should I call the last one? Gender, salary, and marital status. Let me call marital status. Let me put age here instead of salary. This one is gender. So let's say I have like 1, 2, 3, 4, 5, 6. So let's say this person is male, this person is female, female, male, female. Let me erase this one. This one, there's missing value in 2 of them. Now, the age of this person is 30. This is 45. This is 70. There's 70. And this one is missing. This one is missing. This one is 20. The marital status. This one is single. This one is married. This one is. Let me leave this. This is empty. This one is married. This one is divorced. This one is single. This one is married. Okay, single. Let me put that single. Let me put that single. The 20-year-old person can be married. Anyways. Let me put as married. Let me put it as married. So, hello, are you there? Are you there? Are you with me? Hello. Okay. So I have a data set containing this information. This is like 6 records. Now, if I need to, if I need to Say because this table has missing values now, I want to just omit it. I want to omit record with missing values. It means that I'll be omitting this, I'll omit this, I'll omit this, I'll omit this, I'll omit this, leaving me with just one single record. It means because I want to omit records with single values, I just omitted 5 over 6. So let me do 5 over 6 times 100. That's 500 divided by 6. So that's about that's 8, 48, 20. That's like 3. That's I just omitted 83, approximately 83% of my data set. I just omitted that. So that could be so costly. That is very costly. It's not that it could be so costly. So you just omitted majority of your records, and that's going to cost you a lot. So that is why it is not advisable to omit records with missing value. So let's continue before I come back to that. Go to the next page. Now, how do we handle missing data? So some common criteria for choosing replacement values for missing data are as follows. Replace the missing value with some constant specified by the analyst. Second, you can say replace the missing value with the field mean for numeric variables or mode for categorical variables. Another one is replacing the missing values with a value generated at random from the observed distribution of the variable. Also, we have that replacing the missing values with imputed values based on other characteristics of the record. So I will give you an instance before I move on here. Now, so for instance, if I have a role, if I have a job role for a cleaner, if I have a job role for a cleaner, and 100 people applied for that role, 100 people should apply for that role. I believe that majority that will apply is going to be female for a cleaner role. If I need to identify some missing values, I'll be tempted to fill in that missing value by gender, female. Let's say some gender are missing because I expect majority of those that apply to be female. So let's say for example, I have 50% of the whole applications to be female, and I have say 40% of the applicants to be male, then I have 10% to be missing value. Logically, I will be tempted to fill the 10% to be female because I would I would believe that majority of those that should apply should be female. Since I have 50% female, I have 40% male. The remaining missing 10% should be female too because they should be more female than male. So that comes to the idea of missing categorical values with mode and filling missing values with feed mean for numeric variables. I'm coming back to this table that I showed here. So in this table, for example, if you look at this, that's coming back to uh fourth step here. So replace the missing value with imputed values based on the other characteristics of the record. So this is an intuition. If I want to guess the gender of this person now, I can use these two remaining records to guess. Why can I use that? Because if you take a look, for someone at age 20 to be married, I don't expect that person to be a guy. It's just logical. The person can be a guy, but the probability that the person is going to be a lady is very high because Immediately they can marry at that early stage. Or if I even put like 18 years old or 19. So I can tempted to fill in this space value with F. So the person is female. Uh, Maybe I might not be able to do that with this. Maybe I might be tempted to fill in this one as married to based on these two conditions. Say if the person is a female and at age 45, it should be a male unless the person has divorced or the person husband has died. Even if that person has divorced, with divorce is that is going to be a widow. So marriage starts as whether the married single or divorced or separated. I'm tempted to put married here. So that explains that instance. So let's move forward. Now, so identifying misclassifications. So here I have two columns called brand and their purpose. So I have USA here. I have request to be one. I have France request to be one also. I have USA to be 156, Europe 46, Japan 51. Now, here I can be tempted that maybe this USA, France, and Japan can be a sort of misclassification. Then I will just say, okay, I think I will just have to merge. I think I should just merge USA with US to have 157 here. So I'll just merge France and Japan to be into Europe. I just have US and Europe here. So I feel like the rest of them is kind of like misclassification in that regard. Talking about CAPCA methods to identify outliers. So outliers are assumed values that go against the trend of the remaining data. So for example, I can have a test score of some set of students. Say I have 10 students, and and out of those 10 students, 8 students scored 70% and above. And I have two the remaining two students score below 10%. Those two are an example of an outlier. So that could have happened because maybe those two didn't attend classes, they didn't read their book. So you can now try to investigate what actually happened. So it can be because of those two reasons. So those are outliers. So identify outliers is important because they may represent errors. They can also represent errors in data entry. So they need to be investigated. Also, even if an outlier is a bad data point and not an error, certain statistical models are sensitive to the presence of outliers and may deliver unreliable results. So one graphical method to identify outliers for numeric variables is to examine a histogram of uh, of the variable. So, also you can use a box plot also to identify that. Suppose that we are interested in estimating where the center of a particular variable lies as measured by one of the numerical measures of center, the most common which are mean, median, and mode. The measures of central tendency. So the measures of center are a special case of measures of location. So numerical summaries that indicates where a number line is certain characteristics of the variable lies. Examples of measures of locations are percentiles and quantiles. Percentile and quantiles that you say, okay, let's say 25% of these data sets lies in this between this value. So the mean of the variable is simply the average of valid values taken by the variable. But measures of location are not sufficient to summarize a variable effectively. In fact, two variables may have the same values of mean, median, and mode, yet have different natures. It's very possible. Then I think I'll just stop here. Now, variables tend to have ranges that vary greatly from each other. Therefore, data analysts should normalize their numeric variables in order to standardize the scale of effect details as numerator. So what are the various settings must normalize? You have the min max normalization, you have the z-score standardization. I think you have the decimal scaling also. So the min max normalization works by seeing how much greater the field mean is greater. Sorry, how much greater the field mean is than the minimum value, and scaling this difference by the range, which is the maximum minus the minimum value. And we have this standardization, which is very widespread in the world of statistical analysis. Works by taking the difference between the field mean and the field value each of your x or each of your x's and your field mean value, that's your mean, and scale difference by the standard deviation of the values. I think I would like to stop here, but let me see this next slide so that I can. Let's just finish up once and for all. So, the numerical methods for identifying outliers. The z-score method for identifying outliers states that the data value is an outlier if it has a z-score that is either less than -3 or greater than 3. So any value that's outside this interval is going to be an outlier. So variable values with z-score much beyond this range may bear further investigation. However, one should automatically omit outliers from analysis. So let me discuss the two normalization methods. We talked about the mean max normalization and the z-score standardization. So this are it works out. The 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 mean max normalization, the mean max normalization is equals to your x minus the mean of x all over max of x minus mean of x. Max of x minus mean of x is same thing as the range of that particular column. So each of the x, so this is your x, this is your column x, which has some values 2, 3, 4, 3, 8, 9, and stuff like that. So you take each of these values, subtract it by the minimum of this column, then divide by the maximum minus the minimum. So the range, this value lies between 0 and 1. So your min max normalization value lies between 0 and 1. So if you try with this guy now, this is going to be 2 minus 2, because 2 is the minimum. 2 minus 2 is 0. All over the range is still 0. 3 minus 3 minus 2, 1. 1 over 7 is still 1 over 7. Because your range is 9 minus 2, 7. Then 4 minus 2, 2 over 7. Then 3 minus 2, 1 over 7. 8 minus 2, 6 over 7. 9 minus 2, 7 over 7, 1. So it lies between 0 and 1. So it can be lesser than 0 and it can be greater than 1. So we have also this z-score. So the z-score is calculated using the z-score is equals to x minus the mean of x over standard deviation of x. So literally write x minus mean over standard deviation. That's cut. So if you want to write it in R, this is the way you write it in R. This R is written in R. think you can use the function scale to actually do that. Scale. I think this is going to do your Z-score scaling for you. So that's how to find your Z-score value. So moving forward, talking about flag variables. So some analytical methods such as regression uh, require predictors to be numeric. That's so your x's. So thus analysts wishing to use categorical predictors in relation need to encode the categorical variable into one or more flag variables. So here we talk about a flag variable or dummy variable or indicator variable. It's a categorical variable taking only two values, 0 and 1. So for example, the categorical predictor sex taking values for female and male would be encoded into flag variable sex flag as follows. So if sex is female, then sex flag should be 0. If sex is male, sex flag should be 1. So you have to encode your variables into numerical variables and then called flag variables or double variables as zeros and ones. I would like to explain this further, but time is not going to permit us, so I will apologize. I will continue from the next slide. So we are going to continue from the next class, in the next class from here, and uh, we see how far we can go from there. So thanks for your time today. I would continue from there so I can further explain what this is. So that will be it. That will be it for today. Thank you very much.